Start recording. Hello, good morning, everyone. This is Engineer John Paul Dominic Eveloses. Welcome to my video. Today, let's try to explore something new. I was posting chess games last time. I was singing to karaoke, and I don't know what could something that we can do for today, right? So I guess I'm going to share you something, okay? This one, all right. Oh yes, I hope you can see this. I'm sharing my screen right now, and as you can see here, lots of mathematical equations and computation. Wow. By the way, I am currently studying civil engineering, Master of Engineering, major in civil engineering. That's what I was meant to say. And as one of our requirements is to do this kind of homework, right? In one of our class, this is part of a linear algebra topic under advanced engineering mathematics subject. And yeah, and as you can see, I've utilized this software, right? This is called PTC Mathcad. Very useful software. Before I tend to handwritten or handwrite, all of our homeworks, assignments, right? Computations, engineering solutions, something like that. But then I decided this time I'll try to utilize a computer software wherein, you know, most of my calculations, computation solutions will be digitally stored, and can be easily manipulated, right? And can be also saved, and submitted online, right? In any format, Word, PDF, I'm not sure, The good thing is that this software, PTC Mathcad, right? This is very powerful software when we're talking about mathematical computations, right? So as you can see here, this is called PTC, right? Mathcad. This is the version, Prime 4.0, right? And yeah, I've been using the licensed version of it because kung wala kang license dito, if you don't have any license on the software, you'll be restricted in a lots of ways, of its capability, right? So anyway, um, before I will somehow, show you this, I guess, let me try to show you something in the net, I guess, right? Let's see, let's try to search and read something about Mathcad. So this is Mathcad. Mathcad is a computer software for verification, validation, documentation, and reuse of mathematical calculations. This is the best, right? A use of the software, reuse of mathematical calculation. Whatever you problems you computed before, you can reuse it again, right? And besides, it's also, I guess, when we're turning on digital, right, by means of submitting our homeworks, computation solutions, right, by turning to the digital mode, we're trying to save a lot of papers and ink right there. And by saving a lot of papers or paperworks, right, you're also saving the environment. So this is also, I guess, right, environment friendly, right? Something like that. So reuse of mathematical calculations in engineering, science, notably mechanical, right? Chemical, electrical, and civil engineering. As you can see, I'm a civil engineer, and I'm utilizing this Mathcad, very powerful software. This was first released in 1986 in DOS. It introduced live editing, right, of typeset mathematical notation in an interactive notebook combined with automatic computations. It was originally developed by Mathsoft and since 2006 has been a product of Parametric Technology Corporation. So ito pala, this is the abbreviation of PTC, right? PTC Mathcad, Parametric Technology Corporation, right? So if you want to know more about the history overview, right? Capabilities, we can try to read this capability, right? The Mathcad interface allow users to combine variety of different elements, right? So ito, numerous numeric functions, statistics, data analysis, image processing, signal processing, very powerful. Ubiquitous dimensionality checking and simplification, solution to system of equations, right? Ordinary differential equations, partial differential equations. That's heavy math, man. It's very deep math. Root finding for polynomials and other functions, symbolic manipulation of mathematical expressions, parametric 2D and 3D plotting, right? Vector and matrix, that's what the homework or the class that we are right now, linear algebra. That's what I've been using. Curve fitting, regression analysis, statistical and design of experiments, import from and export to other application and types, Microsoft Excel, right? Cross references to other Mathcad worksheet, integration with other engineering applications such as CAD, FEM, finite element analysis, BIM, building information modeling, and simulation tools to aid in product design like AutoCAD, ANSYS, Revit. Wow. Very, very multiple capability type of software. So with that, let's, if you want to read more about this, just search it in Google, in Wikipedia, right? The free encyclopedia. All right. So let's go back to our Mathcad software out here, right? So yeah, before I'm going to explain this to you, right? This is our homework, by the way. Right, let me just add some new sheets, right? So this is a very clear sheet. You can adjust its size in document formatting, I guess. This one, letter, legal, A4 size paper, and then I would like to see it in a fine grid. Of course, the margin, I could save a lot of space there by making it narrower. There are two types of view, you can click here in the corner. This is the page view, the current view that we have, and the draft view, wherein you can put and hide some of your hidden computations. So anyway, the very basic of all is to compute mathematics. So let's try some few arithmetic such as 1 plus 347. Pretty nice answer. Just hit equals, and there you go. It's like an automatic written calculator where you can just print out of typing it. Let's try some multiplication. 3 times 9,203. All right, some random numbers. There you have a exponential form of answer. And with this, if you want to find out other formats of answers that you want, you can just go to math formatting. You can type for decimal, scientific, general, engineering, and percentage. So I would prefer, decimal value, right? Of course, you could also adjust its decimal value or decimal, let's say, decimal points. Let's say 4 decimal points, right? Or 7, I guess. Yeah, something like that. So very, very powerful software. All right. And then what else? Um, Let me see. Are you seeing my screen right now? Hopefully you are seeing my screen, right? All right. So yeah, very powerful software. Let's try a more advanced, let's say algebra. 3x plus 2x. If you hit equals, of course, you can find a definite numerical answer. So it needs some operators. So you click here, math, symbolics, and symbolic evaluation. In just a few seconds, you can get there your final answer, right? 5x, something like that. Of course, there's more and more and more powerful tool in this software. Just see the operators, see the symbols being used, see the programming, the constants that are being saved in the symbolics, right? Very, very powerful software. All right, so let's see. I have a homework here. Let me try to open it. I'm not sure if you can study it. Yeah, this topic is very useful for engineers, I guess. Master of Engineering, Math 611, homework. That's probably page 254, right? This one, right? This is the most detailed homework that I've done last week. So yeah. so this is what I did, I click here outside of the formula box or the Mathcad page box. I click the header and I input the the logo or the school, the name, right? Of course, I also input this. By the way, there are two formats here if you want to input something. There's what we call text. Let's see. If you want to input a text, yeah, you push the button, Control T, right? And then this is a text, right? If you have to direct it, this you cannot. This is not a text because that's a numerical mathematical box, right? So there's two forms. If you input directly, of course, you cannot type a word there because it's automatically the box becomes or whatever you input in the software becomes a mathematical expression or notation, right? So that's why if you want to input some text here, you should apply Control T, right? Or I guess there's an option here as well. Tahoma, document, text block. Yeah, this is what we call text block. Text block is a form of a block. Right. Insert a text region that stretches across the page with text blocks. Push other regions down as they expand. So let's go back to homework page 54. So all of this at the top, my name, the name of my instructor, course and year, date, are all text box, right? This is also a text box. You can also insert pictures, photos. So this one is a screenshot of my homework, right? You just have to copy and paste anything. So let's see. Insert. I don't know if there's an option. Insert here. Document, image. This one. So you find the ribbon and click document and then click image, then click browse for image. And then let's see pictures. Oh, that's my awesome picture out there. And boom, right? So very, very awesome software that we had, right? Oh, yes. All right, so you can insert that one there. Diba? Amazing. You can insert a button here, just like any Microsoft software. But this time around, this is very useful when it comes to mathematical equations and solutions. All right. Okay. So this is just an image, another image, and I type here a text. So let's focus on the math, aspect of this homework. This is the exercises from page 254 of Advanced Engineering Mathematics book. I forgot the author, but I guess that's not important, I guess. But that's a very useful book. I might introduce it soon, right? But this time around, it's focused on the problem. So the instruction is use the method of elementary operations to obtain the inverse of the matrix, right? So this is the matrix. I'm not sure for non-engineering students, if you have encountered this before, probably some math students will encounter this in their linear algebra class. This is what we call a matrix. Matrices are a representation, an array of numbers that represents various types of data in real world, something like that. So our goal here is to obtain inverse of the matrix. What's an inverse of a matrix? Let's read here. The inverse of a matrix can be best illustrated by augmenting an identity matrix or matrix to the original matrix and do some imaginary matrix operations to convert the original matrix into an identity matrix, and subsequently converting the identity matrix into the inverse of the matrix. This was first discovered by Carl Friedrich Gauss. So thank you, Carl, Sir Carl, Master Carl Friedrich Gauss, and later improvised by Sir Wilhelm Jordan. That's why this is called Gauss-Jordan elimination process, right? So the inverse of a matrix is very useful, in a lot of ways, in finding, let's say, lots of programming options in matrix really soon if you go deep enough in the matrix world. But for now, just take it as what it is. This is the definition. This is what matrix inverse is. All right. So I also here inserted some text box wherein there are steps you need to follow, right? So step 1, augment an identity matrix to the original matrix. Augment means you just have to insert an identity matrix. This one is identity matrix. If you see a matrix that are square, right, in dimension, meaning the number of rows of it is equal to the number of column, right? And the diagonal from the first row, first column, to the last row, last column are all a value of 1. 1, 1, 1, 1, right? And the rest are 0. That is an identity matrix. One definition of identity matrix is, I guess, any matrix or matrices that will be multiplied to an identity matrix, the answer will be itself. Just like a multiplication rule, any number you multiply to 1, the product is the same. The product is that number itself. So this is what we do, right? This is the original matrix that we have. We took it from here. We augment an identity matrix, meaning you just put it beside it there. And of course, we tag them R1, R2, R3, R4, meaning row 1, row 2, row 3, row 4. All right. And then there's a step 2. We can begin the Gauss-Jordan elimination by the following operation. So addition and subtraction, right? So this is R1, R2 prime, R3 prime. Every time we reiterate or apply a process in the rows of our augmented matrices, or I don't know if this is the right term. I heard that sometimes they call it reduce row echelon matrix, but that's, I guess, the goal, to reduce the row, right? But anyway, move on. R1 prime is equals to R1 plus R2, meaning R1 prime, this is R1 prime, row 1 prime. You just have to add row 1 to row 2, right? Row 1, the values here in row 1 added to row 2, right? So this is what we got. 1, let's focus here. Negative 1 plus 2, that's just 1. 4 plus negative 1 is just 3. 2 times negative 2 is 0. Negative 3 times 0 is negative 3. And then you got 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 0 is 0. And 0 plus 0 is 0. Right? And there's also R2 prime. Right? As you can see here, we're trying to convert this into an identity matrix by doing some awesome matrix calculations or operations, right? R2 prime, R3 prime, these are the processes that we have. You just have to find some rows that can make that original row into an identity matrix form, something like that. So as you can see here, this identity matrix is converting into something, into another matrix. And this original matrix that you have, you're trying to convert it into identity matrix. So it's somewhat confusing, right? By doing these operations. So let's read. It can be confusing at first, but the goal is to transform the original matrix into an identity matrix, one column at a time. So as you can see, we focus on this column first. This 2, negative 1, 2, 0. As you can see, it was converted into 1, 0, 0, 0. And the rest, we just don't care. It just follows whatever number it might come out, right? Let's convert it on the next step. This can be done by having each row of the matrix transform by adding its factor to the factor of the other row. Meaning, this R1 is a factor of R1, 1 times R1, right? Add it to the factor of any rows that can transform it. The same for this, for R2. The same also for R3, right? Okay. And on our step 2 process, we have to focus on converting column 1 into partly an identity matrix. Row 1, column 1 needs to be equal to 1. So we just add row 1 to row 2 to get the value. Row 2, column 1 needs to be equal to 0. So we multiply 2 to row 2 and add it to row 1. So just explain here. This positive 2, we need to convert into 1 because that's what identity matrix looks like. And what we need to do in order to do that is we just have to add R1, R2. You know, you can see 2 plus negative 1 is positive 1. And then the rest of these numbers will just follow, right? The same for row 2. We need to convert this negative 1 into 0. That's why we did some twice times R2 plus R1. So 2 times negative 1, that's negative 2, right? You add to 2, that will become 0, right? And then the same for this next part of the row. 2 times 4, that's 8. 8 plus negative 1, that's positive 7. And so on and so forth. For R3, right, row 3, this 2 needs to become 0 as well. Look at the identity matrix. We have to slowly but surely, one column at a time, convert all of this matrix into something like this. and subsequently converting this into something else. And that is the inverse matrix. All right. So that's why for row 3, we just did some row 3 minus R1 to make it 0. So 2 minus 0. 2 minus 2 is 0. Negative 1 minus negative 1. 0. 5 minus 2. Right? 7. Right? Negative 1 minus 0, negative 1, and so on and so forth. Now for row 4, we didn't do some operations on this step. Why? Because column 1, row 4 is already 0. No more need for some transformation, right? And step 3, this time we will convert the elements of the second column by doing the following operations, right? Row 1 plus row 4, row T plus 2 times row 4, and then 7 times R4 plus 3 times R2. So the same, this can be very, very confusing for first timers, but this is the easiest, I guess, because there's other step to find an inverse of a matrix. I guess you just have to find its adjugate and find its determinant, right? And then dividing, right? Adjugate over the determinant, and then you can find the inverse of the original matrix. But that's so very complex, much more complex than this. All right. So things just got complicated, as you can see here. Continually column by column, we're converting this into identity matrix. From this, we convert it to this, right? Slowly but surely, column by column. On this next step, from this, we convert it to this. And there are fractions involved, right? Sometimes you just have to use your calculator, you have to easily manipulate these numbers, right? And then there's step 4, right? This is probably the last step, right? Wherein you had to convert the last column by doing these operations, right? And finally, this first part, the original matrix, you converted it into an identity matrix. And the identity matrix, through the lots and lots of processes that you have done here in the previous steps, that's somehow confusing, you convert it into something else. And that's what we call an identity matrix, this portion right here. And the concept behind that is this. A is the original matrix, I is the identity matrix, we augment it, is equals to the original matrix, right? Any number you multiplied, any matrix you multiply to identity matrix is equivalent to that matrix itself. Now, this original matrix, we converted to identity matrix. And by doing that, we converted this identity matrix into something else. And that's what we call the inverse of the matrix. And the inverse of the matrix multiplied to the identity matrix is the same as the inverse of the matrix. So somehow partly confusing. So the final answer for this one, right? Because the goal here is just to find the inverse of the matrix of this is this one highlighted in yellow, right? So partly, in order to highlight this, you just go to math formatting and highlight color. You can click yellow, you can click any color here that you want, but I like it yellow. All right, something like that. All right, okay. So that's the long process. Now, what's powerful here? What's the powerful surprise here in Mathcad? As you can see, I have here the matrix. You need to find the inverse, right? You just have to do this. You have this inverse 1, 2, 3, 4, 1, 2, 3, 4. I mean the original matrix. 4 by 4 matrix. Insert a matrix, just like this. Math, input, matrices, tables, insert 4 by 4. Right. This is the same as this one. 2, -1, -2, 0, right? -1, 4, 2, -3, 2, -1, 5, -1, 0, -3, 3, 2. Ta-da! You have now a matrix. Now, the problem is you want to find the inverse of a matrix. What's the inverse? The reciprocal. How can you put it? How can you do it? Just put a -1 on top of it. -1. I just click shift, right? And then let me see there. Shift, shift, shift. Shift arrow up, I guess. Shift 6. Just have to push press shift and then the number 6, meaning you arrow up and type -1. And here's the surprise, my friend. Hit equals sign. Ta-da! And there you go. You had just find the inverse of a matrix by an automatic calculation of this software in just a few seconds. Right? Right? It's the same as this one. And you might ask me, why, Paul? Why? Why do you need to go all throughout this? If you could just do this in Mathcad. Remember, we're studying here linear algebra, we're studying engineering, advanced engineering mathematics. So it's also best to understand where these computations came from, where these shortcuts came from. That's why it's also important to master the shortcuts, to understand the shortcuts, the powerful software that we had. You need also to understand where it came from, right? Where it originated from. So all of these processes here that I've explained before is what we call the Gauss-Jordan elimination. And the goal of that is just to find this highlighted group of array of numbers that we have. But the shortcut here, in order for checking, just to check if you got the right answers, just in case you're not confident in your manual conversion or calculation, is just to input your original matrix, put some -1 on top, meaning that's the reciprocal or the inverse, and hit equal sign, and then boom, you got your answer, right? So that's finding an inverse of a matrix using Mathcad, right? So I showed here step by step how you can find it manually using the Gauss-Jordan elimination. And I show you also as well how you can do it automatically using this Mathcad Prime software. All right. So I hope you have not been so confused till the end. And hopefully, in this concluding part of this video, you've learned something, right? That this Mathcad Prime is useful in learning, in studying, and solving linear algebra such as this, finding the inverse of a matrix, right? Or any matrices that you want. All right. So I guess I'm going to stop this video for now, and keep learning, keep studying. I might post another video again soon, might be another homework, might be another software, and good luck, and God bless. See ya.